We are very excited to have Jim Carr back with us to share about the joys of mainframes on Raspberry Pi. So Jim, go ahead and take it away.
Thank you very much. I'm going to go ahead and share now. And it apparently is, oh, there we go. It's like, oh boy, it wasn't, I wasn't, share was disabled. I'm like, well, that's a great start, but now it's apparently letting me, so.
You're all good to go. I can see it on my side.
Fantastic. All right. So nothing new here. This is just the same text that we had from or have from the actual meeting on LinkedIn. So, okay, we'll start with a little bit of background, since I know that we probably have quite a few folks on the call who maybe don't know what a mainframe is, or maybe just have a vague idea. There are certainly some things that we envision when we think about mainframes. Hence the picture here, this ancient console computer filling an entire room, big tape drives, and so on. Well, at its core, a mainframe is just a server. You'll often hear when referring to mainframes, you'll often hear the term big iron, just because of the actual size of these machines. And what are they about? Well, mainframes are about two things: processing data in bulk and doing transactional processing. So mainframes in the past and today, it's why I say it's just a server. It's performing that same task, and what they're really optimized to do is to be able to do a lot of that work concurrently and handle incoming requests from many different sources simultaneously, and then appropriately queue and schedule it, and so on. So just a little bit of history. Don't worry, we're not going to delve too deeply into this, but just to give you a little bit of a background, what is generally considered to be the first mainframe came out in April 1964, and heads up, I'm going to be talking a lot about IBM. IBM was and still is the big player in the mainframe space, so very IBM centric when we're talking about mainframes. Now, when I was looking up this information, I was a little taken aback by this number. This is information that's actually coming from the IBM site, so I presume it to be accurate. But in 1964, the System 360, the first mainframe, $5 billion, which translated to, it was updated as of 2012, translated to $2012, this system cost $34 billion, which just, the mind boggles. Now, although this is considered to be the first mainframe, IBM, of course, had tons of success with computer systems prior, but just because of what the 360 was able to do in terms of handling workloads and doing transactional processing, but it checked those boxes for what a mainframe should be able to do. Again, not going to delve into all of these, just a little bit of a timeline here for how the mainframes have progressed from the 70s. This goes up through 2010, but continuing, to today. Now, one item here that I thought was kind of interesting, looking here at March, all the way back to March 1990, Stuart Alsop, writing for in Computer World or Info World, I think it was Computer World. He said, well, obviously, they're on their way out. And he predicted then that the last mainframe would be unplugged by 1996, and mainframes would be no more. Well, by 93, shipments were continuing to grow at 30%, and then you can see from the timeline here that has not stopped. So this was something, when I started learning more about mainframes, that was something of a surprise to me, is just how much they're still used, that they have continued to progress. They're not stuck in the past. They're very modern systems now. So present day, you go to IBM right now, This is their mainframe page. We have these really nice, sleek looking server boxes that represent their Z line now of their current mainframes. So very much still around. And on that note, talk a little bit about perception versus reality. So mainframes, they're outdated. It's nothing but legacy technology that has to be replaced. That certainly exists. There's plenty of legacy code on older mainframes, but mainframe technology itself has evolved. It has kept up with the time. Cloud support, easier to use, current language support, and so on. And then the other one, and this was also a misconception that I had, when I think mainframe, I kind of think of them synonymous with supercomputers, like the something like the Cray comes to mind, where it's this insanely fast doing tons of numerical calculations simultaneously. That's not really what mainframes are about. They are fast systems, but they're more about being able to handle large workloads versus just raw speed. Now, given my focus so far on IBM, it's been all about IBM. I probably should insert a disclaimer. I do not work for IBM. IBM is not paying me to say this. It's simply that IBM really is still the best representation of what mainframes are about. So keep that in mind. Mainframe operations on a Raspberry Pi Zero. Well, why? Why would we want to do this? What prompted this? And a few reasons, at least for me. Now, I'm speaking for myself, but I think that I have some items here that some folks can relate to. It's fun. Resurrecting old technology is interesting. If you talk about vintage computing of most any kind, it's fun to kind of bring that back to life and be able to make that work again. Gaining perspective. How did we get to here? How was it done in the past versus how we're doing it today? We build on our experience of the past, and so that can be really valuable, where you can look at something and say, this concept, this language, this algorithm, this best practice, the list goes on. I see where that came from. I see where this germinated in the past. Learning skills that I can probably never use professionally. Or can I? Article last year, coming actually from NPR, talking about the tremendous backlog of work around legacy COBOL. This was actually a really interesting segment. There's a company in Texas calling themselves COBOL Cowboys. They actually took the name from the I think it was Clint Eastwood movie Space Cowboys, where they had old technology that only these older guys still understood. And that's really what they're doing with COBOL Cowboys. You have this aging workforce still familiar with COBOL, but you still have all of these companies, especially things like state governments, financial, and things like that have this huge investment in legacy technology that they want to maintain, and they're having more and more trouble finding folks who can still work with it. So, believe it or not, in both legacy and current, there is still a lot of work to be found in the mainframe space. But then for me, really what I found most interesting in this is as I first started looking at mainframe emulation. And as I got that working, I thought, okay, I've got this Raspberry Pi Zero, which is very, very small computer. It literally is the size of a stick of gum, low powered. Looking at those two extremes, can we take what was considered top of the line, these huge room-sized systems performing this work back in the early 80s? can we take that and will it translate to the smallest of platforms today? So yeah, just see how far we've really come. You'll often hear the talk of computer in our pocket, where we're all carrying around phones that represent what just a few decades ago would have just been considered this massive amount of computing power. It's kind of the same thing. So can the smallest hardware of today accomplish the tasks of the largest hardware of yesterday? Well, spoiler, yes, it can. That's why we're here today. So what will you need? If you're going to duplicate this setup, you need a host system and you need a client system. So we have our host where the emulated mainframe will run. That's what we're going to use our Raspberry Pi for. And then a client system from which we will connect to the mainframe. Really what we're trying to emulate or duplicate here is the original setup where you would have a mainframe system and then you would have individual consoles connected to that system for the operators to use. And consoles you'll hear them referred to sometimes as dumb terminals because they had no built-in computing capability. It was strictly a screen and a keyboard, and you would use that to send requests, schedule jobs and so on. But all the work was actually done on the mainframe. So that's more or less what we're going to duplicate. We'll use our client system strictly as a connection to our mainframe and let the mainframe do the work. Now that's the setup we're going to use today, but there's all kinds of flexibility here when you're using these emulated systems. It doesn't have to be this kind of setup. It doesn't have to be Linux. You can run the emulated mainframe on Windows. You can connect from Windows. You can use one system for both. If you want a more simplified setup to play around with something like this, you can set up your emulator and then do your connection right from the same desktop, from the same system. So all manner of flexibility here. I haven't actually worked with the Windows version. I've only worked inside Linux for both the host and client, but I do know that there is support on both sides for that. So how do we set up our host? That's where we'll start. Of course, we're using the Raspberry Pi Zero. I should have noted here, as I did below, use the Raspberry Pi Zero W. The W model has wireless baked in, so that saves all kinds of heartache in terms of getting it set up. Raspberry Pi Zero, if you've worked with it before, it's a very small system. It is a single board computer. Everything on one board only runs at 1 gigahertz. It only has 512 meg of RAM, so low power. Low speed. I highly recommend that if you use a Raspberry Pi Zero as your host system, when you set it up, configure it to boot just to the console. Don't load a GUI. A GUI desktop is just going to chew up lots of CPU that we want to reserve for running our mainframe. So that's how I have mine set up. I can load a desktop, but I won't. So what will we actually be loading on the host system? We'll be loading something called the NVS 3.8J Turnkey 4- system. Please memorize that. There'll be a test after. NVS is a mainframe operating system that was created by, surprise, IBM. It's been supplanted now by ZOS is their current mainframe operating system. So NVS is older, and we're using this older version, this very specific version, for an important reason. Over time, some of IBM's older operating systems and other software, some of that has been released into the public domain. 3.8J is the last version of NVS that was released in the public domain. So there are no encumbrances there in terms of licensing. It's not, oh, I found this somewhere and it's not it's very, it's in a gray area for its licensing. Well, that's not the case. You're absolutely free to use this and do whatever you want with it with no concerns about licensing. You can certainly find, there's always ways, you can certainly find newer versions. I don't recommend you do that. You certainly do run the risk of incurring the wrath of IBM's legal team, and why do that? 3.8J, it is older, released in 1981. And it's the turnkey system for NVS that we're going to be loading. Under the hood, the emulator that we're actually using is called Hercules. Hercules is very powerful for a very powerful tool for mainframe emulation. It's also really complex to set up, but we're lucky because we have someone who has done the work for us. That's why it's referred to as a turnkey system. They've taken NVS 3.8J, they've pre-configured it, they've preloaded a bunch of applications, utilities, source code, all kinds of goodies into it, zipped it up so that you can just drop it onto your host system and use it. If you want to delve in and learn more about Hercules, that's fine, but this is definitely the friendliest and most satisfying way to get started because it's just not tedious. And there's everything I just said. So Hercules itself, the emulator under the hood, if you've used any kind of virtualization software, VMware, VirtualBox, QEMU, any of these, it's the same premise. Where you're using something like VMware usually to emulate something like x86 hardware, that's exactly what Hercules is doing, except it's emulating mainframe hardware. That hardware instruction set, it's emulated in the software so that when we run the mainframe operating system, NVS just thinks it's running on real hardware. So what is it actually emulating? For the turnkey system, we're emulating an IBM 3033, and this is actually a picture of a setup of a 3033. The 3033 system is in the back, and then you have a series of consoles with operators set up here in the front. The 3033 was released in March 1977 as part of, there's IBM again, part of their System 370 mainframes. When we're talking about IBM mainframe lines, you'll hear reference to things like System 360, System 370, Z15, things like that. These are very, very broad product lines. They're not a single system. Under each of those, then there are dozens of specific models that are released as part of that line. So when you're running the turnkey system, do you have everything? Does that system look exactly like what someone would be using back in 1981? Not completely. In fact, there are some pretty critical things that are missing, because even though NVS is now open license, a lot of the widely used components or pieces that were loaded into NVS are not. So if you really are interested, pardon me, in learning about the details of mainframes, know that things like 6 are not there, which is a very commonly used application server. You don't have any kind of database server built in, with DB2 being the most common at that time. It's not freely licensed. The vSAM virtual storage access, that's not freely licensed. So there are some pieces there that you won't find, but there's still a lot that you can do with that. So to install it, you go to the NVS turnkey website. A couple of things here. They've got a really good user's manual. So you've got a PDF version of the manual. One caveat here that I noticed, I'm certainly no mainframe expert. And so using this as a tutorial for, oh, I want to learn all the details about what a mainframe is and learn all the terminology, it presupposes a lot of knowledge about mainframes. So as you're going through this manual, it's useful, but as you go through it, you're definitely going to encounter a lot of acronyms that aren't necessarily explained in detail, and sometimes not at all. They just assume that, hey, if you're here to load the turnkey system, then it's because you know about mainframes. So use it, it's good, but also know that there will be places where you'll have to jump out elsewhere and say, okay, they don't explain what this acronym is, so I need to search elsewhere and get the details. So you've got the manual. They keep loads of versions of the TK system. It started with 1.0, and then they have all of their updates. But what you really want to do is go straight to current. The TK4 version 1 current is version 1 with all of the updates applied. So you grab that zip, and then once you have the zip and you've downloaded it to your host system, oops. And I just broke all the things. There we go. So once you have downloaded that to your host system, this is assuming Linux, of course. So if you're loading this in Windows, you'll have to adjust these instructions accordingly. But in Linux, you'll want to go to the opt directory. For creating a directory for NVS to go into and unzipping it, opt has limited permissions, so you will need to sudo these commands. Sudo will just give you admin rights on the commands. So you change to the directory, make a directory for NVS to go to, and then unzip the zip file into that directory. That's the entirety of the installation. Another reason why we really want to use that turnkey system. That's a pretty straightforward installation for what this is doing. So once it's installed, this part is optional. I do recommend you do it because it adds a little bit of functionality to the NVS startup or the session that's running NVS on your host. And I'll show this in more detail. But I do recommend that you turn on console mode. There are two modes. The default is a daemon mode, which just shows a log. But if you turn on console mode, you get the log, but you also get a console view, and you can toggle back and forth between those two views. And the console mode gives you a little bit more information, which can be helpful. Okay, yeah, let's go ahead now and open up a terminal, and I already have my Raspberry Pi up and running, and we're going to open a shell on that system. This is just a script I put together simplifying the connection. Behind the scenes, it's just using SSH, which is a secure telnet, to get over to the system. So now that we're on our Raspberry system, I'm going to switch over to the opt directory. I already have it in place, so you're not going to have to watch me unzip the file. I actually have two instances here. We're going to be working with the LNL1. I have a backup in case I get fumble-fingered and break something. So we'll switch into, we will eventually switch into LNL1. Clear and show it. Okay, so there's our installation. And switching back over here. I've already set console mode, but I'll just show you where that is. In the unattended directory, you've just got a couple of scripts here. And you can switch back and forth if you want. If you turn on console mode and decide that in the future you don't want to use it, you can switch back to just daemon mode, and then you'll just see the logs. But I've already set it, so we don't have to do anything with that. I think I said it. I don't trust myself. I'm setting it again. So again, you'll need a sudo here because you're in a limited permission directory. So sudo do set console, and it's done. So it's turned on console mode, and that's that. So we've done that, and we're ready to start up the mainframe now. So we're already in MVS. The startup script is MVS right here for Linux, and then there's an MVS batch file if you're running under Windows. We will sudo again. We will run MVS, and now our mainframe will start up. So as the mainframe is starting, we're in the log view right now. Hitting escape, I can switch over to console view, and the console gives you information about things like what's going on in the registers, what's the current CPU load, information about individual jobs that are the run state and things like that. I haven't used this a lot. I haven't needed to, but it is nice just to have it available. Just to have it. You can, and I believe you can issue commands from here too, mainframe commands. But I haven't done that. I've always done that from the client console. But it's here if you need it, and then you can escape at any time to switch back to the log view to see the actual status of the startup. You will get some pauses here. Don't be concerned. Sometimes you'll think that it's locked or frozen, whatever, and it's really just waiting on something to start up. Once you see the little TK4 banner here, you know that startup is complete. Your mainframe is up and running, and now it's ready to be connected to. So our mainframe is up. We'll leave this running. Switching back over here. As I said, once the TK4 banner is displayed, that's an indication that your mainframe is ready to go. You can also, similar to what we saw in the console view, the emulator also runs a console view on a port that you can connect to through your browser. So you take the name of whatever your host is and open your web browser on port 8038. Let's just do this. Steal this. I believe I have the name wrong. Bear with me for a moment. There's Raspberry Zero. All right, what did I mistype? Interesting. Oh, I've got 2 colons in there. There we go. That was my fault. Okay, so now that our mainframe is up and running, we can connect our browser to port 8038 on the host, and we've got information about our configuration. A lot of that same info. We can see what's going on in the registers. We can see what's in storage. We can see what the CPU is doing. We can issue mainframe commands. So this is just another way to see that interface into the mainframe. But when we are talking about communicating with the mainframe, really what we really want is a console. Thinking back to that picture we saw with the 3033 installation in the room, those operators sitting at their consoles, That's really what we want to duplicate next or emulate next. So coming back over here, now we're ready to set up our client. This beauty right here is an IBM 3270. It was one of the more commonly used dumb terminals, consoles, used in the 80s and prior. And so we are going to use a terminal emulator that acts just like a 3270 to connect to our mainframe. And it's called X3270. Just like our emulator, our mainframe emulator, there's also Windows versions of 3270 that you can use. And I expect you could probably use other terminal emulators, things like Putty and other tools. I haven't tried that. Since we want the look and feel and the emulation of the 3270, I'm just going straight to the source and using the actual official 3270 emulator. If you're installing it in Linux, you can do it with apt from the command line. If you're running a Debian-based system, you can use whatever package manager you want in your distro. Or if you are using Windows, let's see, do I have a link here? Yes, I do. If you're using Windows, you can actually go to the X3270 website and download the Windows version and install it. So once you have the 3270 emulator in place, go ahead and run that. It comes up. Oh, if you want the real early 80s experience, I talked about consoles often being referred to as dumb terminals. Another term that you'll regularly hear is green screen. Simply because that's exactly what they were. They were generally green text on a black background. By default, the 3270 displays white text on a black background. So if you really want that early 80s aesthetic, you can go into options, you can go to color scheme and switch to green screen. And now when we connect, we'll have our text in green. So we'll go ahead and connect now. To connect to our mainframe, the connection string is just the name of the machine, and it's on and easy to remember because it's on port 3270. If you don't know the host name of the host machine, then you'll need to use the IP address. I do have a host name set up locally, so I can connect to it as RASP0 on 3270. So we'll go ahead and connect. Now we're connected to our mainframe. Here's where it gets a little tricky, because if you don't know how to proceed, because you've just got some text on a screen, you don't have any kind of login. How do what do I do from here? Well, there's some specific steps that you need to take after you connect to the mainframe. And here is where you will want to use the function key emulation. In the 3270, since the X3270 is emulating a 3270 console, we can also send the same commands that we could from a real physical 3270. And you use that by bringing up your keypad over here. On a 3270, on the actual physical 3270 hardware, for example, it didn't have function keys per se. In other words, when we look at our keyboard and we see F7, F3, F8, whatever, on a 3270, it would have been PF7, PF8, and so on. And then there are other keys these are probably mapped to something on a modern keyboard. I don't know what I wish it would show you the actual mappings. The function keys are a little easier because they're mapped where you would expect. I don't have to use the keypad over here for function keys because PF7 is F7 on the modern key. I can just hit F7 here and it'll perform the same function. Things like clear and reset, I don't know what they're mapped to, and it doesn't tell me. So when I need to do these, I just bring up the keypad. When you don't need it anymore, you can just dismiss it to get it out of the way. But when you first connect, to get your log on, you need to bring up your keypad and you need to issue a clear. Clearing will bring you to a logon. Now, if you've been connected for a long time, the screen will actually lock and a clear will not show the logon. I've never seen, I don't know what the timeout is. I've never seen it. I imagine you have to leave it sitting for quite some time. But if you have connected and you've left it for a while and clear is not showing you the logon, just do a reset first. So reset and then clear. So we have our logon now. So I'll dismiss that. Let's make sure that we're on the right screen over here. Okay, no, we're good. So once you have your logon, there are several users that are already set up on the turnkey system. Once we wrap up today, I've got the details of these users documented. I'm going to point everyone to where that documentation is at. So if you want to follow up and do some of this on your own, you don't necessarily have to go back to this video to see that information. You can use the documentation online. But the login that we're going to use is one of the admin level logons. It's Herc01. So Herc01. The default password for, I think, all of the built-in users except one is see you later. It's CUL8TR. Logs in, tells you if you have any messages that you need to respond to. You get the welcome to TSO system. As soon as you get 3 asterisks with the cursor displayed, you just hit enter. You then get a fortune. It's occasional, but I will warn you that every now and then the fortunes are a little bit rude. I've encountered a couple that were a little jarring. So generally it's harmless stuff like this. Little bit of humor. And then once the fortune is displayed, you hit enter again. And now we are at our main screen. Once our main screen is displayed, now we're at and now you can really see the beauty of that green text. But once we reach our main screen, this is where we can actually start doing operations. So let's switch back over here. And yes, ready to proceed with operations. Just as an aside here, I do not have a printer set up. Setting up a printer as output from the mainframe is not a pleasant experience. It's pretty difficult to do, but luckily by default, this is something else that's kind of emulated in that any operations that are done that would normally dump to a printer, which in older mainframes was very common. There was constant output sent to printers. That's captured and redirected to text files over on the system. Over in the opt directory where we had our NVS installation, if you change into the installation directory, you will see a PRT subdirectory. That's where printer output is getting redirected. So if you ever want to check something that you know went to a printer, go to PRT and you'll see text files in there that you can just view. Got ahead of myself a little bit. We just went through all of the logon process. This just gives a little bit of that detail. We got to our initial screen. We issued a clear that gave us our logon prompt. We logged on with Herc01 using the see you later password. We saw the welcome to TSO banner. We saw the fortune cookie. And once we progressed through all of that, we got to our main screen. So this is where we are now. So now we'll do a little bit of actual work. Now I use work loosely because the only work we're going to do is along the lines of kind of the classic hello world type work, uh, just to show you what the process is of opening and editing JCL and source code, and we'll talk a little bit about what that is. So when you're running a job on a mainframe, there are always two pieces to that job. On a modern system, if you want to run a program, you just write the program in the code of your choice and run it directly. Example, if you're running, say, Python, you write your Python script, and then you open up a prompt and you say Python and your script name, and the program runs. If you're using something like .NET, you open up Visual Studio or VS Code and you create your new project, you write your code, you compile it, and then you just run that executable directly. In a mainframe, you can't just run the program. You have to tell the mainframe how to run the program. And that's what the GCL does for you. The JCL is also scripting, but it's script that just says, hey, when this job is submitted and the submitter is asking you to run this program, well, here's how you do that. Here's an important gotcha. This definitely tripped me up when I was first working with it, is when you're running programs in the mainframe, all of the source that I saw have a message class. It has to have a message class that tells it what to do, where to send the output from the application. They're all defaulted to A, and A just gets swallowed. When you run it, it sends the output somewhere. I'm not sure. It doesn't even go to that print directory I was telling you about, which is what I would have thought would happen. It just disappears. So you write your code and you submit it, and then you don't see any results, and you wonder what you did wrong until you find that, oh no, change your message class. The ACE just says hold. It says rather than just sending the results on to the void, apparently, hold them so that they can be viewed and you can see what your program actually did. Now, that was all very abstract. We're going to show you a real result here. Now, we're going to be showing examples in 4 different languages on the mainframe. For all of these, you've probably at least heard of them. I'll venture a guess that if you're actively working in any of them, it's probably C. I could be wrong, but we probably don't have any day-to-day COBOL or Fortran or PL1 programmers here. But we'll touch on each of these. And we'll start with COBOL. So COBOL, another language that's been around for a very long time, first released in 1959. It's meant to be English-like, and boy, if ever you needed air quotes around something, it's applicable here for English-like. It's verbose, certainly. English-like, well, you can be the judge of that. And there's still tons of it. There's tons of COBOL out in the wild right now. So the reference that I saw was that as of 2017, it is heavily used in financial, banks and so on. 95% of the time when you do an ATM swipe, the processing behind the scenes to handle the details of that ATM swipe, it's hitting COBOL code. And even 80% of in-person transactions still have a lot of COBOL handling the details behind the scenes. So I don't know how comforting that is to anyone, but it is what it is. So, all right, let's get to some actual code. Now, on our main screen here, you will see the first 2 options here. You will see RFE and RPF, both described as SPF-like because we need acronyms. You can never have too many acronyms. But SPF is a tool structured program facility, I believe, that was the most commonly used interface for consoles connecting to mainframes. In other words, when an operator connected to the mainframe, it was SPF that was presenting options to them for doing, for submitting jobs, for checking output, and things like that. SPF is another one of those tools that is not in the public domain. So we can't use SPF directly, but there are a couple of free implementations that duplicate what SPF does. I haven't used RPF much. I just happened to, the tutorials that I was looking at happened to use our RFE. So that's where I spend most of my time. But when we're working with source code, with applications here, you go to RFE, you go to utilities, and then we will go to DSList. It will actually show the contents of the data sets on our mainframe. So we'll pause for just a second and we'll talk about data sets. Because when you're on a mainframe, you work with data sets and members. And that equates directly to what we understand on modern systems as directories and files. So you have data sets as a way to group members, just as you would tend to put files into individual directories that kind of represent, what those files are. If I go to DSList now, so when you're going to DSList, when you're getting ready to list data sets and their members, well, here is where you specify, well, do I want to look at a subgroup of the data sets? And we do. Really, the only thing we're interested in while we're working on the mainframe is working with our the JCL library where our source code is. So we'll say when you're showing me the list of data sets, reduce it just to the data sets that start with sys2.jcllib. So we'll leave that as is. I'll hit enter. When we get to here, we don't need to issue any commands here, but on sys2.jcllib, we need to tell it whether we intend to view or edit. And we are going to be doing some editing here. So I'm going to enter an E here in the first column of the sys2.jcllib line, hit enter. And now we actually see a list of the members inside sys2.jcllib. Page up and page down inside the console maps to the PF7 and PF8, which is F7 and F8 on your keyboard. So I'm hitting F8 to go down, F7 to go back. And as I go down through the programs here, we want to use the simplest versions that they have, and it's the test programs. We're starting with COBOL, so we're going to look at TestCut first. I hit tab a couple of times to get my cursor into this column, and then I can just arrow down once I get to here. Now I already instructed RFE that I wanted to open the data set in an editable mode. So I entered an E. But you also need to specify individually on the member whether you intend to edit or not. So same rule. If I just want to view it, enter a V. If I want to edit, enter an E. And here's another aside, because it's another gotcha. In fact, this tripped me up just last night. This was very frustrating, is that if you accidentally say view and you open the member, it will let you edit this as much as you please. So if you come in here and you forgot that you came in here in view mode and you make a bunch of edits and then go to save, it says, nope, can't save in view mode. And I could not figure out how to get out of it. I did all kinds of Googling and tried can I reset? Can I cancel? Can I undo? And Never could get out. I literally had to disconnect, log in as a different user, and shut down the mainframe to release everything. So, yep, sometimes you'll encounter stuff like that. And that's why it's good to know that you have multiple users defined. When you're playing around in here, if you get stuck in something that you just cannot figure out how to get out of, just remember which user you were logged in as, probably Herc01. Go up here and just disconnect. Just disconnect the session, reconnect the session, log in as Herc02, and shut down your mainframe. And we'll go through the process of that as well. Shut down the mainframe, and that'll release everything. And then you're good. It's tedious, and there's probably more straightforward ways to do it. But that was the path that worked for me. Okay, so once again, I'm about to forget that I'm in view mode, so I want to back up now. F3 is what you use to go back. The path that we took to get here, we can step all the way back through that by just continuously hitting F3. So F3, I'm back to the list. F3 again, I'm back to this, and so on and so forth. All right. Now, we can edit TestCut here directly and submit it as a job if we want. I'm actually going to make a copy. So the reason I would want to do that is because, you know, I'm not a COBOL expert. I'm not a JCL expert. So it's always good to have this as a template. So if you want to play around with COBOL or any of these other languages, don't modify these directly. Make a copy of them, and then you can always go back to them to get a fresh copy. So to do that, I'm going to go back up here. I'm going to go back up to my command line. See my cursor right here. And in order to do that, then what we're going to want to do is indicate to the console or to the mainframe that we want to start a new file. So you prefix it with S, and then you give it a name. And I'm just going to call my this will add a new member to the data set. So I say S, I'll call it Jim Cobb. So this is going to be Jim's COBOL program. So I hit enter, and we end up with an empty file. I want to go to my template, my TestCut, use that as a starting point. So in order to bring that in, then I just say copy TestCut. Now I'm working with my own copy, Jim Cobb, but I've brought in the contents, a copy of the contents of TestCut. Now, when I was talking about JCL and source code, I told you every job that is submitted on a mainframe has to have those two parts. The actual source code of what you're running. Now, this can be source code, it can be mainframe commands, but you always have to also tell it how to run them, and then the JCL is what does that job. So the JCL in a member file is always prefixed with 2 slashes. So it's easy for us to see where the JCL ends and where our actual program begins. All of this is JCL. All of this is our COBOL. So we got a very simple example here. All this does is our classic hello world. Now we're back to where I was describing this as English-like. Again, you can judge for yourself how English-like you consider this to be. Yeah, I'm kind of ragging on COBOL because I do think it's a kind of funny what was considered English-like back in the day. In order to run this, we only need to make one small change. Remember, I warned you about the message class. If you use the default of A, it will disappear into the void. It'll run, but you'll never be able to see the results. I don't know where they're going. But if you change your message class to H, then they will be held there's another area in RFE where we can actually go to see the results of our running of the program. So I'm going to go to message class. I'm going to change that to H. That should be all we have to do. Now I'm going to go back up here to my command line. And from the command, then I will just go ahead and say first save to save the change that I just made. And then I will submit. And then submit then is saying, okay, I've got this member file open. I am ready for the mainframe to actually process it, to interpret the JCL and the source code and do what it's telling me to do. So I'll go ahead and submit. It lets me know that it has been submitted. If I switch now over to here, remember where we started up NVS and it's logging information about what NVS is doing? We can see right here that the hello world job was submitted and then it ended. I don't see any errors here. That's a good sign. If I go back over to NVS now, I'll hit F3 to back up, F3 again, F3 again, and again, and again. And when I get to here under our dataset utilities, we went into DSList to see our list of members. We can now go see the results of jobs by going to Outlist. So I'll go to 8. And once I go, once I open Outlist, it starts with a limited set of job results. You're not seeing all the jobs that have run here. To see them all, you do ST asterisk and hit enter. Once I do that, here at the end of the list, we see TestCut. Now, the reason it's saying TestCut and not GemCob is because even though the member was named GemCob, the job name, the description in the JCL, we didn't change that. Probably should have, but we know what we ran, so it's easy to spot. So inside the JCL, it's still referring to it as TestCut. Okay, so if I then go down here and here I go to the line of TestCut, I say S and I hit enter. And this is everything that was output when that job ran. And it's usually pretty lengthy. So if I start paging down through here, inside the COBOL code, there was a section there where it actually output the text hello world. So if it worked as expected, we should eventually see hello world. All right, where did it put it? Well, that's awkward. So it ran. We got no errors, but I'm not seeing my hello world message. So I'm either missing it. Oh, there it is. I expected that to be at the end. Reported a bunch of other information as it was wrapping up the run after it output the text. But right there is our hello world text that it dumped out from our program. So we successfully copied, modified, submitted, and successfully run our COBOL program. Now going back to DSList, let's see, how are we doing on time? Okay, we'll run. We'll at least view the other three. We'll see how we are on time before we decide if we're actually going to run all of them. But I'll go back to JCL lib. I will go back to go into JCL lib in edit mode again. Oh wait, and if I page down, I didn't even note this. You see that now there's that the new member there with GemCob, the copy that I made. But I'll continue on down. Let's see, what's the next one? I think our next one is Fortran. Fortran, another really old language. also released in the late 50s, was and still is widely used, mostly for numerical processing, scientific and engineering applications. Still a lot of Fortran used by, for example, NASA, because they have a lot of this proven code written in Fortran, and they continue to use it. So looking at our list here, let's go down to, yeah, we're getting a little close on time, so we'll just view this one, just have a quick look at the Fortran code. So I went into this in view mode. Similar layout, we've got our JCL telling it how to run, and then starting at line 18 here, we have our actual Fortran code. This is also a hello world example. And they are actually running two different versions. They are using Fortran G and Fortran H in the same, and that's kind of important to know, is you can mix and match. As long as you have JCL telling the job how to run, you can have modules from different language versions and even different languages in the same job, and run them all. So here we've got it just saying hello. I love the optimism here. Doesn't seem that they were terribly confident this would work, but it does. But we have the same hello world code being run using the Fortran G compiler and the Fortran H compiler. I'll go ahead and back out of that guy. Who's next? PL1. Not used so much anymore, but like anything else, there's still some of it around. It is still used in some areas. Not quite as old. PL1 first came out in 1964, but still active. I mean, still around. Latest version, pretty recent. Now, if you're working with PL1 in the turnkey system, boy, this was another one that was tough to find, because this is not in the turnkey cookbook doc. I had to do a lot of Googling to figure out why my PL1 jobs weren't running. There's a critical statement missing in the test PL1 programs. They require a job lib statement. The code as it exists in the examples out of the box, it tries to run the wrong, or the reference to the PL1 compiler is wrong, and it's the job lib statement that tells where the PL1 compiler is. So you just need to add that to your JCL. If we go back over here, so right there is our test PL1. You will need to do, and this I actually will show you because there are a couple more editing commands that you'll want to know how to do in the editor. So I will go up here and I will say, let's see, make sure I use the right one for PL1. Yeah. Okay. So same command actually. So you do S and you say, I'm going to call this one Jim PL1. This will open a new empty member. So I do that, and then I do copy test PL1. We get the contents of PL1 up here in our JCL. We've got the job section of the JCL, and we just need to come to the end of that and add an entry for the job lib. Here, it's not obvious how to insert. Now, you can just arrow over and type to make code changes, which we'll want to change our message class so that we can see the results. But it's kind of hard to see, well, how do I insert a line? Well, to insert a line when you're in the RFE editor is you make sure that your cursor is, you make sure your cursor is positioned over in this column, and you do I and enter. That will give you a new line, And now we will enter our joblib command. So that's joblib dsn lib. Let's see, did I get that right? Oops, no, I didn't. Well, I'm making it worse. Okay, so dsn equals sys pl1 lib. There we go. I'm not sure what the disp is doing here, but the dsn is just an indication of, hey, when you try to run this, when you take this source code and you run it, this is the utility that understands how to run this. You're overriding whatever the default is and saying, go use this pl1 lib utility to execute this code. Without it, it will fail. All right, so we changed our message class. We added our joblib line to tell it how to run. And with that, then we can go back and we can, as long as I didn't fumble finger anything, we can save, we can submit. Let's see what it tells us. So test PO, oh, I forgot to rename the job again. Oh well. So it started, it ended, don't see any errors. I think we're good. We'll hit F3, 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 and we'll just keep hitting F3 until we see Outlist again. We'll go into Outlist, we'll show all, and there's test PL1. And go see what we got. Right, so if I page down through PL1, where are you? Hello. Boy, that's verbose. There it is. So it did run. So I didn't mess up. I didn't mess up my joblib line like I thought I would. It did run successfully, and it output hello world. So now we've successfully run some PL1 code. Go back to DSList. Go in edit mode. And our last language example, that would be C. C is a little bit newer. C's been around since '72. C is still very actively used. So still the most actively used by far. With C, it's not just about legacy work or niche type work. C is still heavily used in operating system development, kernel development for writing device drivers, widely used in embedded development. So yeah, still huge footprint for C. In fact, if you look on the, I think it's the TOBE list of language usage, I believe C still sits at the top. It's really dangerous. And that's really the biggest gripe about C is its memory management. You have to know exactly what you're doing, or you will run the real risk of corrupting memory and having your program fail. But it is very powerful, and that's why it's still around. C is as close as you can get to the hardware without going to something like assembly or machine language. And C, for all its quirks, is a heck of a lot friendlier than assembly and machine language. So looking at our list, we'll run our last test here. Now, here's another gotcha. I don't have an answer for why this is. It's just something you need to be aware of. They have two different C compilers installed in the turnkey system. The GNU C compiler, and then the JCC, that is Dignus Systems, I believe. Not even around anymore, as far as I know. But the Dignus C compiler is the only compiler that works. I spent quite a bit of time trying to get the GNU compiler to work and was not successful. So if you're going to play around with C, unless you figure out what's wrong with GNU, If you're going to play with C, I suggest using the Dignus compiler, so the JCC. So we'll start another gem JCC, and then we're going to grab a copy of that.
Jim, just let you know you're at 15 minutes remaining.
Oh, I know. I'm getting very close to the end. Thank you, though. Okay.
For your questions, everyone. Prepare them.
Sorry? Did somebody say something?
No, I was just warning everybody to have their questions ready to go.
Okay. All right. So we have to make the the standard fix here of switching our message class. And on this one, I was actually a little unhappy with the complexity. This doesn't feel like a simple hello world to me. What they're doing with this one is from their main here, they are just building the 99 bottles of beer on the wall song, which, okay, that's kind of cute, I guess. But it's a pretty wordy, pretty verbose program. So we're actually we're going to scale this down a little bit and just make it super simple. And here is the other command that's useful inside the editor. I showed you how to insert lines. To delete lines, you just go to the same column and use D instead of I, and then that removes the line. So we're going to remove our processing for the beer song, and then we'll go down here, and this is not relevant anymore. So I'm just going to insert and do printf and say our good old classic hello world, and then delete this. And one other thing in here that I don't like, it runs. The Dignus compiler is apparently pretty forgiving, but there's technically a bug here. It's because this C program is expecting to return a value, and it doesn't. So that irritates me. So we're going to fix that. There. So now we have our C program that's really been scaled down. It's been made much simpler. It just prints out a hello world. It returns a value as it's supposed to. We updated our message class. We'll go back up here. Now, see, now I can almost guarantee, with all my griping about how I didn't like how they did things in the program, I probably got something wrong in here to teach me a lesson, but we'll see. So we'll save, we'll submit, we'll switch over here. Test JCC has started. Uh-oh. What did I just say? So this one's taking a little longer than I would have expected. Give it just a moment. Oh, okay. It ended. Don't see any errors. Back up again to our Outlist. Test JCC. Let's see what we got. Page down. Oh, okay. So it's apparently happy. There's our hello world that we added. We replaced our beer song with just a simple hello world, and there's the output. Okay, so we saw how to work with 4 different languages inside the emulated NVS system. We successfully modified and submitted 3 of them. So now we will move on. So, okay, old languages. Why are they still so actively used? And I found a term that I really liked, and it is inertia of legacy, which is also a great band name. Inertia of legacy, it's just referring to, it's actually another way to say sunk cost, I think, as much as anything. We've put all this effort into it, it works, we're not going to throw it away as long as it works, because we have all this in place. And so that's why you still see a lot of the usage of these old languages. We know what we have is well tested. People understand how it works, and it's just not worth the effort of throwing it out and starting over. So now finally, we've reached the point where we've brought our system up, and now we're ready to wrap things up and shut down the system. So when you're finished working in a mainframe session, you'll want to F3 back out to your main menu, and actually you need to go one step further. So once you're on the main screen, you hit F3 one more time to get out to, now exited the TSO, the timeshare screen. Now you can issue mainframe commands directly. And here it's where if you're just finished working, you can just log off. And now I can just disconnect if I want. My mainframe will continue to run, and I could come back. I could leave this up, or I could reconnect and log back on. But if I'm truly finished, you may be recognized soon. Hide. If I'm truly finished, then I will want to exit out of the TSO system. Tell it that I am now want to shut down. And since I'm running as Hercules 1 that has the high level of admin type permissions, it will recognize that and process it. So I'll shut down. I will log off. I will disconnect. And if we go over here, this usually takes a couple of 3 minutes, but it has initiated the shutdown. You can see the message right there. It will go and just cleanly close open files, shut down unneeded programs in a clean fashion, and just it's not just, you're not just throwing the power, just turning the power off. It's cleanly exiting out of everything, and will eventually come back to the terminal prompt. And with that, we conclude kind of our broadcast day. If you have questions outside of this that you want to ask, feel free to reach out to me at jfcar@gmail.com. And I've also put together a support repo right here under my account, Mainframe LNL support. I'm actually going to put that in the chat if I can get to it.
You beat me, Jim. I was just starting to type it over.
So if you go to the LNL support repo, several things of interest here. So for working with languages, the changes that I just talked you through on the four languages that we worked with, I've got before and after. I can make words. Before and after examples here. The original file as it exists inside NVS, a version of the file with the needed updates, and I also went ahead and generated diff files for you so you can quickly see what those changes are. If you want, you could come here and view the changed version. If you want to just quickly know what needed to be changed, look at the diff file and it'll show you what the change was. Most of them are simple. It's just that message class. Others, for ones like the PL1 where it needed the job lib statement, that tricky little statement, the diff will show that as well. So you've got sample code there. Have a wiki with a few articles here. I've got a glossary where I try to, and I'll update this if I find more, but I tried to pick out like some of the acronyms, some of the other terminology that you see as you're working through this, and just give you definitions of what that actually is. I also gave you instructions for the stuff that we just talked through. So you have a reference here. If you want to go through it yourself, you've got reference documents that you can pull up and use, and then also some useful links. I won't go into detail about all of these, but I will call out a couple that I think are really interesting. Bit Savers being one. Bit Savers is an effort to scan and digitize tons, and I do mean tons, of old documentation for hardware and software documentation. And I can tell you from experience that you can really go down a rabbit hole here. If I go into computing, for example, if I go down to IBM, I go into the IBM folder, we were just talking about the 3033 mainframe that is being emulated inside the turnkey system. Well, here you can see a couple of the original manuals for the 3033. Click through, and then here's a scan of that document from April 1979, as it happens. So if you want to see original documentation, this is a good source. And then the other, if you are interested in mainframes, and especially learning more of modern mainframes, the IBM Z Explorer. IBM maintains comprehensive training information at IBM Z Explorer. You actually get modern mainframe access. You can write jobs, write code, submit it to a real mainframe, a remote, nothing for you to set up. You just write your code and submit it. Really nice. I just signed up for this. I've just gone through the first section, but it's pretty slick. You install a extension in VS Code that gives you the ability to view jobs, view data sets, make copies, do edits. Really nice. So if you're wanting to pursue more and learn more about mainframe operations and how to be a mainframe developer, this is a really good resource. And then I got links to the NVS homepage, compilers that are supported in NVS, a couple of C references, more information about the Hercules emulator. And then finally, there's a discussions. If you want to pop in here, if you don't want to email me directly, or if you want to have group conversations, you can pop in here. You can ask questions. You can just give feedback, things you liked, things you didn't like about the presentation today, suggestions for other topics, whatever you want. It's open. You can, except I forgot to make it public, which I knew I would. I will do that right now.
And Jim, we'll put links to this on the Smartdata website as well.
Okay.
So, I want to get people out on time.
Yeah,
so
sorry, I know I'm coming right to the wire.
I'm playing the Emmy music for you now.
Yeah, it's getting louder and louder, and then the big hook comes out and drags me off stage.
Well, thank you all so much for coming.
I'll have to come
Jim,
back.
you got a couple minutes to stay after?
Oh, sure, but yes, thanks. Sorry that I took it right to the end, guys. But thanks for coming. I hope this was interesting for you. But I will make that public as soon as we wrap up, and you'll be able to access that. So thanks, everybody.
Yep, and this video will be available online here probably in the next week. So if you are interested, want to share it with a friend, want to go over something that you missed or want more details on, we'll have that available here soon. So thank you all for coming, and we will see you at the next one.